Okay, hello everyone. So today we're going to discuss two-sum. It is an example of data structure and algorithms. It is a very common interview question actually if you go for Facebook or Google interview. So let's see. Two-sum. Let's see the description of this problem. Okay, so given an array of integers, return the indices of the two numbers such that they add up to a specific target. So you may assume that each input would have exactly one solution, and you may not use the same element twice. Now, what we're going to do is analyze the given problem. So given an array of integers, so we have, for example, this array, we would need to return the indices of the two numbers. So it is important for us to keep note of their indices. So let's put the indices there, such that they take note of that, to a specific target. So our target is 15. Now, if we look at this array closely, it would be easy for us to identify that that two numbers that would add up to our target 15, which are 9 and 6. So these are these two values. But how are we going to do that? We can actually apply a brute force solution. So for a brute force solution, we can start on the first index. So that would be our slow cursor. We would have two cursors actually. So we can keep track of the slow cursors with the red box and the fast cursor with the green box. So for this first and second cursor, the current sum is 14. The indices are 0 and 1. So what we wanted to have is that the sum would be equal to our target. So we will run through the array. So the fast cursor will go through all the values on the right of the slow cursor until it finds the target. So 5 and 9, which has a sum of 14, is not the same as the target of 15. So we go to the next one, which would have the sum of 8. And then the next one has the sum of 9. And 5 and 8 has a sum of 13. 5 and 2 has a sum of 7. And 5 and 6 has a sum of 11. So since we have gone through all the values of the array, what we're going to do is move the slow cursor on the second onto the next one. So okay, now we have 9, and then we'll start again right after the slow cursor. So 9 and 3 has the sum of 12. 9 and 4 is 13. 9 and 8 is 17. 9 and 2 is 11. And then finally we reach 9 and 6, which has 15. Now that we have that value, we can actually return the indices 1 and 6 already. So how do we implement this one? So public in solution. So normally when we create a solution in our interview questions, we only implement this method. We don't normally implement the entire class anymore, just this method. So okay, so what they're expecting is that we would return an array, so the result of the indices. So since we only need 2, so we can initialize it at 2 and return it at the end. Okay, so to implement our slow cursor, we would have a for loop which would start at index 0 and would run through the entire length of the array. The fast cursor would be inside this for loop, which would start at the index right after the slow cursor, so it would always start with I plus 1 and will go through the entire length of the array as well. Now, we would add up the values of array I and array j, and then we would get the sum, and then we will compare it with our target. So if sum is equal to the target, then we can already set the index 0 to I and the index 1 to j, and then the result, and return that as our result. So if we look at this, the time complexity is O n squared. because we are going to the array this much. So there is an inner loop, there's an outer loop and an inner loop which goes through the same array. So time complexity is O(n) squared. We would have another tutorial for for the explanation on how we can identify the time complexity. Okay. So for now, what is the best way actually to implement the solution? So let's try to look at the problem once again. So this is the problem, and if you have noticed earlier, even though we have already calculated the values for the example 5, I mean, for example, we have already calculated the values. We have already seen 3, we have already seen 4, we have already seen 8. We have to go through all of them once again. So what if we would create a lookup table? So what is the purpose of this lookup table? If we have already seen a value, we have already checked that one, we will just put it in this table and take and remember it. And then from there, if we go through another value, we would just check if the partner of that value is existing on the table. So to further explain it, for it to be for it to be clearer, let's run through an example. So for example, let's start with the first index. So 5. Now 5 and 0. So what we're going to do is check if there is a partner for 5 here in this table. So to know what the partner is, we would going to subtract 15 minus 5, which is 10, and see if 10 is already here. So since it's not, we're going to put 5 in the table since it's something that we have already seen. So let's put it there. 5 and 0. So take note, we are putting the value and the index as well. Next, we go to the next value. 9 and 1. Why did we put it here? Because 15 minus 9 is 6, and 6 is not yet on the table. Okay? So for the next value, 3. 15 minus 3 is 12. So let's look at the table. Is 12 existing in the table? Not yet, so let's put 3 there. Next, 4. 15 minus 4 is 11. Is 11 in the table? No, so let's put 4 here as well. And then 8. 15 minus 8 is 7. 7 is not on the table, so let's put it there as well. And 2. 15 minus 2 is 13. So let's put 2 here and 5 here because 13 is not on the table. And finally 6. 15 minus 6 is 9. 9 is already on the table. So we can already return the index of this because we already know, we have already seen it before. And we can also return the index of 6 because we know that the partner is here. So as you can see here, we would actually have to run through the array once. So imagine if 6 is not at the end, and it's on the third index. You only have to iterate through the array. You only need to go to the first 4 index because 5, 9, 3, then this one is 6. So you know that the partner is already here. So you don't have to check the entire array anymore. So how are we supposed to implement this lookup table? Okay. So to implement that lookup table, we can have a hash map which would hold an integer and integer. So what would be the integer and what would be the key? Because as you know, hash map is a key value pair. So what would be the key? The key would be the value. So it would be 5934826, and then the value would be the index. Why is that? Because on our result, what we actually need is to return the index and not the actual value. And for us to search the table for the existing partner, we are looking for the value and not the index. So to explain that, here is how it goes. As I mentioned earlier, we would need to go through the array only once. And so we would only have one for loop which should start at the first index and run through the entire array. We would have two variables. So to find is equal to target minus array I. So to find is to look for the partner. So we would need to know if the partner is already in this table. And integer val found is equal to map.get to find. So this would hold the index if the value of the partner is found in this table. So let's see how it works. Later on, it will be clear as we will go through the code line by line. So if we didn't find the partner in this table, what we mentioned earlier is to add that to this lookup table. So we're going to have map.put. We are going to put the actual value and the index. So the actual value is the key as mentioned, and then the index I. Otherwise, if it's already found, so result 0 would hold the val found, so the value found in this table, and then result 1 would be equal to I, so the current index that we are in, so we return the result. Okay, so this is our solution. So let's start with the index 5. So let's run through it. So index 5, our target is 15 minus 5, that's to find map.get 10. So 10 is not in the table, so it's not found, so we're going to put the partner, the value and index. Okay, map.put. Now, next value, 9. 9, so 15 minus 9 is 6. So we're looking for 6 for the to find value. Is it in the map? So 6 is not here, so it will be null, right? So map.put, so we're going to put it there again, and then 3, it goes like that again. It will loop until, okay, until we reach the index 6. Okay. Alright, so we have put everything. Now we are on the last one. So 6, index 6, right? Now to find target minus array I, which is currently 6. So it's 9. So we are supposed to find 9 on the table. Map.get to find 9. So val found. So it's this one. Since this time we have found the value, so it's 1. So we are going to this else block. So result 0 is the val found, which is 1. And result 1, I, which is currently 6. So return the result. So that is how the best solution for this problem works. So we created a lookup table, and then we have also tried the brute force solution. So comment below if you have any questions, like and subscribe if you learned something today, and watch again for our next videos for solution discussion of the problems that we have. So we're going to discuss the problems we can see online that are normally asked during interviews, coding interviews specifically. So if you also have any problems that you want me to discuss and to explain to you, then comment it also below. Alright, thanks again everyone. Hope to see you soon. Okay, bye bye.